All right, guys and gals, so we are in section 10, more similar triangles. So we're going to see a little repetition of using similar triangles to solve for x, but we're going to look at a couple new ideas, okay? So what we have here today is what is called indirect measurement. Indirect measurement can allow us to find unknown lengths when it is not possible to measure a needed length. Okay, because that length is way too tall, it's a building, it's a tree, or something like that. One way to use indirect measurement is to form similar triangles within the shapes that you have, because we know similar triangles are proportional. We're going to discuss the most common ways to create similar triangles using an indirect measurement. First is utilizing the shadow of two different objects, and the second is using a mirror. So the first thing we're going to look at is when you have two objects outside and they both have a shadow being created by the sun, and you know the height of one of the objects, you can use that idea to find the height of the other object, okay? So if I have two objects here, okay, let's say that as a person, I'm standing here 5 foot tall, okay? I have a 3 foot long shadow. A tree here, I do not know how tall this tree is, and it has a 9 foot long shadow. So these two scenarios I could have contain similar triangles because I would be standing perpendicular to the ground, the tree would be standing perpendicular to the ground, and the tip of the shadow towards the sun, they'd both have the same angle to the sun at that instant. They would then have, these would be similar by angle, okay, so the shortcut. So this scenario again, if I have similar triangles, we know the sides are proportional. The mathematics here isn't too tough. We could set up a proportion like maybe 5/3 could be equal to x over 9. Remember that there's lots of different ways to set this up. You could say 5/x equals 3/9. Okay? But once you set up that proportion, then we know we could set cross products equal to each other. Okay? So we're going to have some applications, some word problems today where you might have to label the picture yourself. So then 45 would equal 3x. Divide both sides by 3. The height of this tree then could be 15 feet tall. On example B, let's say now we have a person that's 5.5 feet tall. We have a tree here. We do not know how tall it is. There's a 2 foot shadow and a 6 foot shadow. Again, these two triangles would be similar by the angle shortcut. Let's set up a proportion to solve. 5.5/2 could equal x over 6, or 5.5/x could equal 2/6. Again, right here, cross products equal to each other. 5.5 times 6 is 33. 2 times x is 2x. Divide both sides by 2. X could equal 16.5. Okay, so that's one way to use indirect measurement if you have shadows for two objects. Okay, the next idea is that we could use a mirror. Okay, so let's think about this. So I have a really tall tree standing outside. I have a really tall tree here. I want to know how tall it is. I could place a mirror on the ground in between myself and this tree. Okay? And if I was to walk backwards until when I looked down at the mirror, I could see the tip top of this tree. That's how far I need to walk backwards. Okay? So it's almost like a little science experiment. When I do that, I would create two similar triangles. So from my line of sight down to the mirror and back, the angle from my line of sight to the mirror back to the top of the tree, those two angles are congruent. This person would be standing at a right angle. The tree would be at a right angle. So again, these two triangles here would be similar by angle. Not as common now that we have as much technology in the world, this mirror idea of being able to use that to create this distance. So the distance, I would then be able to measure the distance of the mirror to the tree, the distance from me to the mirror, and then I would know my height. Then that unknown height then would be that object, the tree or the building. Okay, so here's an example of that. So I, again, could be 5 foot tall. My distance from myself to this mirror would be 7 feet away. The mirror's 49 feet away from the base of the tree, and I do not know how tall this tree is. Okay? So then the proportion that I could set up might be 5 over 7 equals x over 49, or 5 over x equals 7 over 49. Cross products equal to each other. 5 times 49 is 245. 7 times x is 7x. And then dividing both sides by 7 to get x by itself, I could have that tree is 35 feet tall. Okay. Let's look at another example of that. So this time we're measuring in centimeters. Let's say that I'm 175 centimeters tall. I placed a mirror on the ground 600 meters from the base of the tree, and I had to walk backwards 200 centimeters until I could look down at the mirror and see the top of the tree. Okay, so then this proportion might look like 175 over x equals 200 over 600, or 175 over 200 equals x over 600. So this part here is a little bit of a review, setting up these proportions. When you cross multiply here, 175 times 600 is 105,000. X, 200x on the other cross products. Divide both sides by 200, and then x is 525 centimeters tall. Okay. So that's two ways of using indirect measurement. Now we're going to look at some overlapping triangles. So another way to create similar triangles is when they are overlapping. So these two triangles are similar because they are both have this right angle, but they are both sharing this base angle. So we have this large triangle. Now what I need you to do is to draw these two triangles out. Okay, so in between the two examples of A and B, draw two triangles, and we need to label them. This is the important part for today. This is the brand new stuff that I need you to really focus on. So this large triangle has a side length of 15, but the bottom is this little chunk of x, 6 and x. So this whole side is 6 plus x. So again, draw these triangles out and label them. And then the little triangle has a side length of 7 and x. If you can draw them out separately and label them correctly, you're going to be golden, okay? So now we're going to go ahead and solve for x. The mathematics here is sometimes a little bit more complicated because we might have to distribute because we have this x plus 6. We've been dealing with that though. So if I set this up, I might say 15 over 7 equals x plus 6, 6 plus x over x. Well, we're going to set cross products equal to each other first. So 15 times x, and then 7 times 6, and 7 times x. And some of you right here would write like 7, open parentheses, x plus 6. Okay, so 6 times 7 gave me the 42. 7 times x gave me 7x. So now I have x's on both sides. I would subtract 7x from both sides. And then divide both sides by 8. My answer is going to be 5.25. This is what we're going to do a lot of practice on today. Is this a problem that looks like this? Okay. The next one is little triangle has side lengths of x and 5. The big triangle here has a side length of 26 and 18. So this line that's drawn around this 26, that's indicating that that's that whole side. So we're not going to write 26 plus x on this one. So 26 is this actual whole length. Bless you. So we want to get used to being able to see the large triangle in the picture and then the little one. Once you have those drawn out and labeled, then we again set up proportion because the triangles are similar. Maybe x over 26 equals 5 over 18. Again, there's lots of ways to do this. You might write 26 over x equals 18 over 5. But again, we're going to set cross products equal to each other. 18 times x and then 5 times 26 is 130. Then divide both sides by 18. And this one we get 7.2. Now we have a couple problems here, word problems. And the challenge on these problems is to decide, am I going to start with an overlapping situation like this, or will they start in separate situations? So let's go ahead and read these and find out. So a lamp is 20 meters from a bush that's 2 meters tall. The height of the light is, or height of the lamp is 10 meters tall. Find the length of the shadow that's being casted out by the bush. So right here it's saying that this lamp is a certain distance from the bush. So this is a lot like our shadow unit problem, where this is going to be an overlapping situation to start with. Okay, so we have this lamp that's going to be 10 meters tall. It's going to be 20 meters from a bush. The bush is going to create a shadow of a certain length. So our object here, and we want to know what its shadow length is. So in this instance where we have the light that is creating this shadow, this is overlapping, and then we need to draw these triangles separate to solve. So the large triangle has a height of 10, and the base here is 20 plus x. The little triangle over here has a height of 2 and a length of x. So then that proportion 2 over 10 equals x over 20 plus x might be one that you write. Set cross products equal to each other. Again, right here, 2 times the 20 plus x. I distribute. 2 times 20 is 40. 2 times x is 2x. So I have variables on both sides. 10x equals 40 plus 2x. Variables on both sides, subtract 2x from both sides, leaving me with 8x equals 40. Get x by itself, I'm going to divide by 8. And then this last example here, I have an 8-foot tall bush casting a shadow that's 4 feet long. At the same time, I have a tree that's casting a 10-foot shadow. So notice that there's no light source being provided here. I'm not going to start with an overlapping situation. Okay, I have this 8-foot tall bush has a 4-foot shadow. At the same time, I have a tree. I do not know how tall it is. It is casting a 10-foot shadow. So you start separate triangles on this problem. So then a proportion I might write might look like 8 over x equals 4 over 10. Set cross products equal to each other. 80 equals 4x. Divide both sides by 4. And that tree would be 20 feet tall. Okay, so that concludes section 10 notes.